So we had talked before about our special right triangles, and I again kind of want to walk us through this. If you were watching the Khan Academy videos, they do it slightly different than the way I do it, only because they're kind of prepping you for what's coming next, which is something called the unit circle. I prefer to just keep fractions out of the picture as long as I can. So when I do this, I know that if I'm talking about a 45, 45, 90 triangle, that this is probably not drawn to scale very well. It comes from the idea of a square. And in a square, all sides are equal. Right angle. And when I do a diagonal in a square, it's going to bisect those angles as well. Well, nice thing about this is I know these two sides, no matter what they're going to be, are always going to be the same thing. So I'm going to call that x. So what would this side here be? That would also be x. In a right triangle, if I have two sides, what do I do to find the third? Yeah, a squared plus b squared equals c squared. So that's what I'm going to do. Even though it's a variable, it's okay. So I'm going to do a squared plus b squared equals c squared. What is x squared plus x squared? Nope. 2x squared. Thank you. So this is 2x squared. And then how would I find what c is? What would I do to solve that? I want to get c by itself. Take the square root. So when I take the square root of both sides, I get that the hypotenuse, what is the square root of x squared? X, and then I have the square root of 2. So I like this rather than dealing with numbers simply because, well, all I need to do is set like an equation equal to what I have left and find the missing piece. Now, some people will do this as a ratio where they will say the hypotenuse over your side. The hypotenuse is going to be square root of 2. The side is going to be 1. And as long as you always put hypotenuse over the side, you can solve it like a proportion as well. And I'll show you both ways. Okay? So, looking at number 1, I'm actually going to start this off just to show you the ratio. It's really not that bad. You're going to say the hypotenuse over the side. So, what is the hypotenuse here? 4. Give me one of my sides. Okay. So, all I do to solve this is say cross multiply x root 2 equals 4. Then what? Beautimus. What? What? Rationalize. I thought for some reason my brain heard hot dogs. So that's why I was like, what? I don't understand. Yes, how do we rationalize that? Yeah, that was totally random. Multiply top and bottom by root 2. So root 2 times root 2 is 2. So this is 4 root 2 over 2, or 2 root 2. So this is 2 root 2. This is 2 root 2. The picture method is exactly the same thing, where I would just take the side that they give me and say, okay, in this case, 4 is my hypotenuse. My hypotenuse is x root 2. And then if you notice here, that's the exact same equation we have over here. And a little bit of a hint for you guys. When you are going from a hypotenuse to a side, you're always going to divide by the square root of 2, which means you're going to tack on a square root 2 and divide by 2. Because you see, that's what happens here. You get a root 2 here over 2 when you rationalize. And we're going to keep practicing that if you're sitting there going, what? So if I have the leg, How do I go from a leg or a side to my hypotenuse? What's the difference between here and here? Not divide by 2. If I want to go from just the x, you multiply by the square root of 2. So I will have 3 root 2 over 2 times 2. Times the square root of 2. And what is root 2 times root 2? 2. So when I look at that, these puppers will cancel out. So I will have my hypotenuse is just 3. What is this side over here going to be? Yeah, it's the exact same one that we had on the other side. The nice thing about these guys is the rules are not going to change. The nasty thing about them is we're going to have to deal with our radicals. Okay? And we're talking about special right triangles. You're not going to be using your calculator for this. I mean, you might have your calculator for this test, but if you give me a decimal, you will get no credit. Do you understand what I'm talking about there? You give me a decimal, you will receive no credit. Because my goal here is these are called simplified radical form. And so what I will say is I will say leave your answers in simplified radical form, or sometimes we just say exact. Because if you're going to do a decimal, you have to round to write it down, no matter what. So if you see either the word give me the exact answer or simplified radical form, that means no decimals. Decimals are almost as bad as whoever took their entire test in red pen. I don't remember who it was, but I'm yelling. Don't do it. Why is that you, Hayden? You had like a very guilty smile on your face there. He was like, nope, I just think it's funny. All right. Go ahead and read the problem for number 3. See if you can draw a picture that goes with it. Yay, I got the okay to pass back your tests today. All right, is everybody familiar with the shape of a baseball diamond? Yeah. And for baseball, it is basically a square, because I like saying it like that, and that is a really horribly drawn square, where we have first base, I was going to spell out second, right first, makes sense that way, second base, third base, and home. Okay? And we're saying for high school, the distance from base to base is 60 feet. So that means that each of those are 60. To the nearest foot, how far does a catcher throw the ball from home plate to second base? This is what I'm solving for. Can anybody give that to me in simplified radical form? Go for it. 6 radical 2 or 6 root 2. I don't care which one you want to say. 60. There's a 0 involved there. And there's one more thing. Feet. Words in the problem need words in the solution. Now, what's nice here, I don't know if you caught it. Did you catch it? What do my instructions say? Nearest foot. If I'm talking about nearest foot, what does that involve? Rounding. So what can I use? Decimals and your calculator. So grab these wonderful, wonderful, powerful tools. These are so awesome. And I don't care what kind of calculator you have, as long as the calculator that you have for this class has sine, cosine, tangent, y'all good. Okay? All right, so I'm just going to do 60 square roots of 2. Enter. What is that to the nearest foot? 85 feet. Yes, I'm a pain in the tuchus. 85 feet. You leave off the words, you leave off credit. Okay. These idea of special right triangles are hugely important for all of trig because it comes to be like the keystone for what we call our unit circle. But this unit that we're doing right now, we are just going over right triangle trig rules and general triangle trig. Okay, we'll do unit circle next, but this unit is all about right triangles and general triangles. So, we had also talked about our 30, 60, 90 triangle. And we said that comes from an equilateral triangle, where each angle is 60 and each side is the same. But to build my 30, 60, 90, I take one of my angles, I bisect it, and because the type of triangle it is, it also bisects this side down here. This ends up being 30. So what I do, because I don't fractions with this, I try to keep them away as much as possible, I'm going to call this x, which kind of means this piece here. 2 of those x's, because again, 2 of them make up the whole piece. And what would I do to find that? Okay, yes, but if I've forgotten all of my rules. Pythagorean Theorem. That's where I was going with that. Thank you, Theo. So, Pythagorean Theorem would say x squared plus something squared is equal to my hypotenuse squared. Whoops, that square goes on the outside. Big difference, big difference. So what is 2x quantity squared? If I square that, what do I get? 4x squared. So my missing side squared becomes what? When I subtract x squared from both sides, what am I going to get? Thank you. 3x squared. And then, for the folks that were already giving me the answers, that's where the x root 3 comes from. All I want you guys to see here is if you've completely forgotten your special right triangles, if you know your Pythagorean theorem and just a little bit about geometric properties, squares and triangles, you can always rebuild those rules. Makes life a lot easier. So for that, this is my short side. Please notice small angle opposite the smallest side. Biggest angle opposite biggest side. That's your triangle inequality theorem. And then 60 is opposite the leg. So the way that we have that as a ratio is we can have the short leg, the long leg, and the hypotenuse. Where the short leg is always 1, the long leg is the square root of 3, and the hypotenuse is 2. I know that looks really weird for a ratio, but if you're doing that, you would only then need to pick out the pieces that you'd want to work with. So for example, if I had the short leg and I was looking for the hypotenuse, I would just use 1 over 2. All right. So I kind of like to pull these apart by what makes sense to me. I look at this is 16. X or Y, what can you easily give me looking at that picture? 8 for Y, good. Because if that's 60, this is 30. That's your smallest side. And ladies and gentlemen, please understand, these things, don't trust that they're drawn to scale. I don't make all these worksheets. I definitely prefer that they are drawn to scale. But sometimes in the 30 go. So pay attention to those. Not drawn to scale. All right, so that's 8. What then is this guy? 8 root 3. Beautiful. Now, when I give you the hypotenuse, if I look at this triangle here, if I give you the hypotenuse, what do I do to this to get the short side? So what is 8 root 5 divided by 2? 4 root 5. It's not a decimal. You can just take the whole number and cut it in half. Now, once I have the short side, what do I do to get the long side? And let's make sure everybody remembers how to do that. not 8 root 5. We're talking about the short side is the 4 root 5. 4 root 5 times the square root of 3. What is that going to give me? Beautiful. 4 root 15. Okay? All right, I want you to read through problem number 6. See if you can solve that on your own. You're welcome to work with a neighbor for that. Here we go. Whoa. I see some really icky looking faces. Would you like me to start over? Okay. So let me get a clean little sheet here. Let's start this over. Perimeter. So here, let's just look in. It's okay. Breathe. We got time. Just so you guys know, all we're doing today and tomorrow is special right triangles, trig, angles of elevation depression. Okay? No quiz next class. Breathe. Breathe. So, I know it's going to be an equilateral triangle. That's not a bad equilateral triangle, if I do say so myself. And I was told that the height of that equilateral triangle, which is this guy right here, makes a right angle, is 4 feet. Now, this is going to be 60, so that's going to be 30. I need to figure out how much wood, and the wood is what I have up here in blue. Okay, so that perimeter. So the problem is I need to move probably from the hardest side. So I look at this, and if I kind of go back to what I had x, I had 2x, and I had x root 3. So I'm going to say 4 is x root 3. How do I get the x by itself? Divide by the square root of 3. And when I divide by root 3, just to rationalize that, that's going to work out to be 4 root 3 over 3. Y'all on the same page with that so far? So that's this piece. I want to know what that piece is going to be. What is that piece? Yep, because you take that and you times it by 2. 4 times 2 is 8. So that's 8 root 3 over 3. You with me so far? We okay? No, totally clueless. Speak up, please. Making a little bit more sense? All right, and then here's the thing. I want to know how much wood would it take? How much wood would a woodchuck chuck if a woodchuck could chuck this? You can either add them. Right, because something plus itself is the same thing as 8 root 3 over 3 times 3. And I just like that better because those will cancel out and leave me with 8 square roots of 3. 1, 2, 3. And yes. So some people would say, I'm going to take this plus it. That's just the harder way of doing times 3. So that's why I did that. Doing all right here? Bless you. Unclean. Not funny. You chuckled. Okay, I just couldn't tell. Thank you. I needed that. All right, and then when you put that in a calculator, you get 13.856. And we're going to try to get you used to that idea of constantly rounding to the same thing, simply because if you take calculus next year, in calculus they have rules for their grading, and their standard rule for calculus is always rounded to 3 decimals, always round to the nearest thousandth. I had to think for a second there. All right. I want you guys working together to try 7 and 8 for me, please. All right, so for number 7, I got 5 root 2 over 2. And for number 8, I got 15 over 2. I was like, we were supposed to do 8? I will be more than happy to walk through 8 with you. What? It's okay. What's your question? Oh, sorry. Just looking. Okay, so for these lovelies, you start off with what you have. And if this is 5 root 2, dividing by root 2 just makes that sucker go away. And so I have that each of these pieces are 5. Then we get the joy of dividing by the square root of 2 again. And it doesn't have a root 2 to cancel out this time, so I have to do 5 divided by root 2, rationalize, and any time you divide by the square root of 2, that's always the same thing as root 2 over 2. So whichever one is easier for you for that problem, for this, dividing by root 2 is easy because I can just cancel it out. For this one, divide by 2, tack on a square root of 2. Okay, this one's a little bit more in-depth, but we start off with, of all of them, the nicer side. I think that's nice because to go from here to here, you get 5. You divide by 2. Then, to move from the short side to the long side, you say times by the square root of 3. And then we get to do the whole thing all over again. Song. Thank you. Okay. And then again, once we have a hypotenuse, we're going to say 5 root 3 is my new hypotenuse. Cut it in half. And then times that by the square root of 3. And root 3 times root 3 is 3. 5 times 3 is 15. Was that a swish, David? Noise. Dana, can you see okay from over there? She's like, yeah, no. Girl, where's your glasses? Get glasses. They're awesome. Look at how glorious these glasses are. They add character. personality and eyesight, which is always a good thing. Okay. Dun, 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 dun. Trig ratios. I saw size there. Trig ratios. Who knows how to remember your trig ratios? SOHCAHTOA. Okay? And I even probably write it differently than some of you guys do, because I actually write it the way they set up. So I say SOHCAHTOA. And I write it like that because sine, cosine, tangent, those are my ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Some old hippie caught a high tripping on acid. I did not come up with that. Our former Prince William County Teacher of the Year came up with that. You're welcome. So if she can do it, so can I. So, what we have here, we have a right triangle. Here is my right angle. We have A, B, and C. Now, for this problem, you see this symbol here? Does anybody know what that's called? That is a theta. I'm going to pop a theta right there. And all of our trig ratios deal with where is the placement of that angle. So no matter what, here's my theta. That side is my opposite. You can always go to right angle across points to the hypotenuse, which leaves me with what? That means that's the adjacent. And so, remembering our trig rules, sine then becomes the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is the opposite over the adjacent. Does anybody know what this stands for? Cosecant. I'll even spell it out for you. Cosecant. Whereas this is secant, and this is cotangent. And I want you to look at how I've got these guys paired up. Every pair has a co. Sine, cosecant. Cosine, secant. Tangent, cotangent. So if you forget which ones pair up, always remember that one thing in your pair is always got to be attached to that little co. To me, it's just something that helps. Now, does anybody know what the cosecant is? Right, it is just the reciprocal of these guys. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. So you can use all of these trig ratios to help you find a missing side or a missing angle. But don't forget, if you have two sides and you're missing a third, what always works in right triangles? Pythagorean Theorem. A squared plus B squared equals C squared. Do not forget one of your favorite little toys in this class. It helps us a lot. Now, when I ask you to find the trig ratios for theta, if I say trig ratios, I need all 6. So that means you're going to need to give me the sine of the angle, the cosine of the angle, the tangent of the angle. And by the way, this is not sin, cos, and tan. It is sine, cosine, and tangent. And then you're going to give me the cosecant of the angle, the secant, and the cotangent. So do not tell me sin, cos, and tan, and always write down your angle symbol, because depending upon what is in here, those ratios will change. So, here's my angle. Sine is what over what? Got a little problem with that. What's my little problem with that? I don't know what that dude is. How can I find him? Pythagorean Theorem. So I'm going to set that up. I will say 3 root 5 squared plus my x squared is 9 squared. Now if I take 3 root 5 and square that, what do I get? It's not 15. This square goes to the 3 and to the square root of 5. So 3 squared is? Root 5 squared is? So 9 times 5 is 45. And 9 squared is? So x squared is then going to be equal to what? $36. So this side here is 6. Everybody okay with what we're doing there? The dumb questions are the ones you don't ask. That have nothing to do with this class. Yes, thank you. Question. Stop it. When we get there. Okay. Okay. What you looking at? Uh-huh. Ding, ding, ding. What do? Simplify. Sine is opposite over hypotenuse. You must always simplify every fraction, rationalize if necessary. So 6 over 9 simplifies to 2/3. Cosine is going to be what over what? Adjacent over hypotenuse. So what's the adjacent? So 3 root 5 over 9. What is that going to simplify to? Root 5 over 3. Beautiful. Ick. This one's a little grosser. What is the tangent going to be? Opposite over adjacent, where opposite is 6, adjacent is? Ugh. So that's basically 2 over the square root of 5, right? And to rationalize this, I'm going to turn this into 2 root 5 over 5. And I did not give myself enough room to write those. Heavy sigh. No quiz on this next class, just more practice on this next class. Okay. Then when I do the reciprocals, look at your simplified version and do what with it? Flip it. Flip it and reverse it. What's this one going to be? Oh, dang girl, you got it. 3 root 5 over 5. Buddha must. Now, if I look at this one, and I flip it, I'm going to have the square root in the denominator. So what I'm going to do is I'm going to back up a step to when I started to simplify and I had 2 over the square root of 5. And I'm just going to flip that one. So it'll be root 5 over 2. If I were to have to kind of do the reciprocal on this problem here, 2 root 5 over 5, the reciprocal would be 5 over 2 root 5. That's just ugly. So I try to look back in my work and see if there was a simpler place to do a reciprocal. As I was simplifying this, I said 3 goes into 6 twice. So I had 2 over root 5. The reciprocal of that is just root 5 over 2. So I was trying to figure out what's the easiest way to do this for me. And the rationalizing the denominator, that's going to be your hardest thing that you have to work with. Okay, for all of this stuff, that's going to be the hardest. So I want you guys to do the same thing. On number 10, I've given you all of your pieces. So all you need to do is find your 6 trig ratios. All right, here, let's see what our answer was. Ready? Rationalizing some of these guys were ugly. Sometimes I make mistakes, so let me know if you see something. Yes. Okay, and there's a lot of folks that have been having questions on that one, so let's just work that whole little piece out. So you're okay with the 5 over 10 root 2? So I have 5 over 10 root 2. The easiest thing to do there is to simplify. 5 goes into 5 once, and into 10 twice. So I have 1 over 2 root 2. Then who's causing the problem in that? The root 2 on the bottom. So to rationalize, I times top and bottom by the square root of 2. And root 2 times root 2 is 2. But then there is that other 2. 2 times 2 is 4. And that does not simplify, even though you really, really want to. Okay? That is going to be the hard. It's not, it's just so easy to mess those up. Okay? I'm going to do one more problem, and then I know that I've got folks that are heading out to a college visit in the something, right? I don't know. Which one is it again? George Mason. All right. So it says find the cotangent if the cosine of an angle is 13. So all I'm going to do, this helps me out a lot. I'm going to draw a right angle, and I'm put my theta someplace. I don't care where you put it. Now, cosine is what over what? Adjacent over hypotenuse. So that'll be adjacent over hypotenuse. Cotangent is what? Adjacent over opposite. So what do I need to do in order to figure out what the cotangent is? Pythagorean Theorem. Let's go call that A. So I will have A squared plus B squared equals C squared. What's 3 squared? 9. 13 squared. So A squared is going to be 160. Now, I need to simplify that. You've got to be able to simplify your rationals. So I look at that and I see 16 times 10. What is the square root of 16? 4. And 10 is just 2 and 5. I can't do anything with that. So that means my adjacent is 4 root 10. So my cotangent is adjacent over opposite. Oh man. What do I need to do? Rationalize. So my cotangent ends up being what? Beautiful. All right, now my folks, we're going to... no. I'm going to go over it, but I'm letting some folks go. Okay, so for those of you that are going, your homework is actually the very back page of all of this. Okay, so I know there were 2 people that talked to me first. 1 and 2. Yeah, toodles. I'll see you guys a little bit later. Go ahead. All right, so just go. So I have an answer. Uh-huh. This is my angle. That's the adjacent. That's the opposite. So sometimes I'll actually go ahead and write opposite, adjacent, hypotenuse, or H, A, and P, and O. I know it because I put the A there. That probably is what threw you off. So I want you guys to try 12. See if you can work through number 12. It's the... You guys think you got it? What is it? 9/17? That's right. It's 9/17. I just wanted to kind of psych you out a little bit. So when we do this, please make sure when you square stuff, the 4 gets squared, becomes 16. The root 13 gets squared and becomes 13. 16 times 13 is 208. Boom shakalaka. Wiggle your way down. You get to that missing side is 9. Price is feeling good. Some of you are in happy places. Some of you are like going, what? Some of you are like Jacob and just doesn't want to be here, period. Like, yeah, it's the truth. It's okay. You don't have to like it. You just got to put up with it. Okay. Wow, there's a lot of stuff for this trig, right? In geometry, you spent a whole unit on this. We're doing it in a day. No! No questions. Just kidding. What's your question? No, what you just did is you took 4 times 13. But when we're squaring this whole thing, the 4 gets squared as well as the square root of 13. Okay? See, Crystal, you're just in the up and down seat. She's like, yay. Any other questions on that one? Okay. All right, now this is, like I said, we're doing all of a full chapter of geometry in one day here. So a little bit of stuff to remember doing. If I just asked you to find the value of sine, cosine, or tangent, all you're going to do is you're either going to write the ratio, or type it into the calculator. So for example, I will either say find the value of sine, cosine, or tangent, and it will be, for example, opposite over hypotenuse. Or I will say find the value of the sine, cosine, and tangent of 25 degrees, and you will just go to your calculator and plug it in. Okay? So it's either going to be a fraction or type it in. The reason your calculator got different answer, I want you to look at the top of mine real quick. You see that right there? It says degree mode. So hit your mode button. Go down and you want your degree highlighted. Yep. We'll be doing radians later. For the most part, though, if we're using our calculators, we're going to be doing degrees. Okay, did everybody hear that? If we're going to be using our calculators, we will be doing degrees. So if it says trigonometric ratio for an angle, that's the same thing as above. So that means you're just going to write your fraction. So that's going to be your SOHCAHTOA stuff. So that will be something like 4/5. If it says to find the missing side, the thing that you need to know is that you are going to use on your calculator the sine, cosine, or tangent buttons in order to solve an equation. Whereas if you're going to find the missing angle, you're going to use basically the inverse, which is done by doing second sine. Most of you probably won't even need to refer to those first 4 things. It's just a reminder, when do I use my buttons? So, when I am looking at problem number 13, my x, what is that? It's a side, right? X is a side. So we can even kind of like pretend that's not even there and just deal with the things that I do have. I have an angle right here that's 66. I have this piece, and I have this piece. If that is my angle, x is my opposite. 3 is my hypotenuse. And you will see me, no matter how many times I do this, I always write my SOHCAHTOA where I can see it because I think it just makes life easier. Which one of those 3 uses opposite and hypotenuse? Sine. So I'm going to just set it up. The sine of my angle, and that's in degrees, is opposite over hypotenuse. This is just a ratio. This is just an equation. How do I solve that equation? How do I do that? Multiply both sides by 3. So I'm going to have that x is 3 times the sine of 66, and I'm just going to plug that into my calculator. So I'm going to say 3 sine 66. I am in degree modes because I can see it across the top of my screen. And I'm going to read, I don't know what, let's not do hundredth, let's do thousandth. Because I believe that's what we stick with for everything. So when I round that out to the nearest thousandth, what are you going to get? That's it. Remember doing this stuff a couple years ago? That was way back in the day. It's just because you haven't done it for a while. As we go on, you're going to go, oh, that's what that's doing. Okay. Your Pythagorean triple, 6, 8, 10. That's what you're talking about. Okay. So let's look at number 14. Again, what is it that they give you? They give me this. They give me this. They give me that. So, if this is my angle, 8 is the side opposite. X is the side adjacent. Which trig ratio is opposite and adjacent? Tangent. So I'm going to say the tangent of my angle is opposite. Whoops, Why am I writing the opposite? I'm just going to put those numbers in place. Opposite over adjacent. It's just a little bit annoying to try to solve, but solve it we will. We can do this. You can solve this problem. How do I solve this problem? If I multiply by 8, it just becomes multiply by, even if I multiply by 1/8, I will get rid of the 8, but I have the x in the denominator. So what? Denominator. So times it by x, get that x out of the denominator. Now how do I get the x by itself? So 8 divided by the tangent of 51 degrees. Calculator. 8 divided by the tangent of 51 degrees. Boom! Shakalaka! What's your answer gonna be? 6.478. Beautiful. Epic win. Yes. I like that, Theo. Heavy sigh? You exhausted yet? Yay, math first thing in the morning. Woo! Only thing that's worth is math at the end of the day. Yeah, me too. End of the day, my brain is fried. All right. Might be that I don't have an x here, but that's okay. I'm still going to do this the exact same way that I've been doing it. Here's where my angle symbol is. I have that. I have that. So if that is my angle symbol, 10 is the opposite and 13 is adjacent. Which trig ratio is that? Tangent again. So the tangent of my angle, I just don't know what it is opposite over adjacent. When we are finding a missing angle, what do we use? Yeah, so we want that inverse. So I'm going to do the second tangent so that it says tangent to the -1. And that's get the theta by itself, and I put the 10 over 13. That's it. So second, it is called inverse tan. Inverse tan, 10 over 13. Boom. What is it? Good. And be very careful. What is this that I just found? An angle. So what do I have to do? You have to add degrees. It's very, very important with angles because if you don't add the degree symbol, that basically is saying that you're measuring it in something called radians. The degree symbol tells me I'm measuring it in degrees. When it's not there, angles are measured in radians. So it's a completely wrong answer. Okay, here's what we're going to do. If you'll notice, we still have word problems on this, right? Why don't we save that for next class? So what I want you guys doing right now is you will notice on the back of your handout, you have this guy. I want you working on 1 through 18. That's what your homework for tonight is going to be. And that's what you'll have time during Flex today to work on also. Okay? We do have Flex for this class. Today is Flex 1, 2. All right, so again, I want you guys working on problems 1 through 18. Okay? That way next class, we'll finish up what we call our angles of elevation depression problems, and we'll practice. Okay? Yes, ma'am.